Hi everyone, this is Tanu Rajput and my teammates are Kajal Dhu Naveen Kumar Sambhari. Here I am going to explain about my caption project Fuel Bike Sharing Demand Prediction. As we all know about the traffic, which is the biggest problem we face. To rectify this problem, government has launched many mode of transports. Among them, bike sharing is the one. So, what is the problem statement here? Here, currently, rental bikes are introduced in many urban cities for the enhancement of mobility comfort. It is important to make rental bike available and accessible to public at right time as it lessens the waiting time, eventually providing the city with a stable supply of rental bike becomes a major concern. The crucial part is the prediction of bike count required at each hour for the stable supply of rental bikes. Now, in this project, we will discuss about the data description, exploratory data analysis, correlation analysis, multicollinearity detection, all models evaluation, matrix, and model selection, challenges we faced during the project, and at last we will discuss about the conclusion. So let's start with data description. Here we have a data set of Seoul bike data in which two columns are related to date and time, which are date and hours. Some columns are related to weather like temperature, humidity, dew point temperature, visibility, snowfall, rainfall, wind speed, solar radiation, and seasons. And some other like rented bike count, holiday, and functioning day. So these are some features of our Seoul bike dataset in which our output is rented bike counts. So let's take a glance at the data set. Here we have 8,760 rows and 14 columns, and there are no null values in any feature. If we observe the date column in data set, it begins from 1 December 2017 to 30 November 2018. That means we have exact 1 year of sure bike sharing demand data. So from 14 features, our target feature is rented bike count and rest are independent features. So now start with our EDA part. Let's see the box plot on rental bike counts with respect to season, hours, year, and weekdays. In count over seasons, the demand for bike in winter is less than compared to summer and other seasons. In count over hours, if we observe during the day, the demand for bikes is high from morning 8 a.m. and from evening 6 p.m. So coming to our next slide, let's see the visualization of no holiday and holiday and months. Demand for rented bike counts during no holiday is higher than the holiday. Now in count over month graph, if we observe carefully, the demand for the bike is lesser in the months which are December, January, February. At that time it is winter season. In month of such as April, May, June, the demand for bike is higher because these months are fall in summer season. As we all know that the count of bike rents are higher in summer. So coming to our next slide, in which we will see the visualization of rented bike counts per hour during weekdays. So here from Monday to Friday we consider as a weekday, while Saturday Sunday considered as weekend. If we closely look into the point plot, either it's weekday or weekend, the demand for rented bike counts approx start from morning 6 a.m. At 8 a.m. it is high, and also from 6 p.m. The bike count is high in weekdays than weekends. So the bike count is high in weekdays in comparison to weekends. So now coming to our next slide, we will see the visualization of rented bike counts per hour with respect to month. In this visualization we can observe that in month of December, January, February, the demand of for bike is less due to cold weather. And although the pattern is same with respect to hour, as demand gets peak at 8 a.m. and 6 a.m. So coming forward, let's take a look on rented bike counts per with respect to season. So we have already seen before in box plot that the demand for the bike in summer is high and in winter is low. So moving forward, let's take a look on visualization. Here are some pie charts of on distribution of categorical features. From this pie chart, so we can observe that month feature is equally distributed, and in holiday features, no holiday is 95% and distributor and 5% of holidays, and in season column all season label is 25% distributed equally. Now in the next pie chart, in the year column, 2017 are 8%, in 2018 there are 92%. So coming to our next pie chart, which is of functioning days, here 97% are yes, it is functioning, it is on bike rent on functioning days, and there is no bike rent, 3% no bike rent on functioning day. Okay, now let's see the distribution of target column. As we know, our target column is rented by count. So here we can see in the this plot the shape of rented by count features is rightly skewed. We have to inform this distribution into approx normal distribution using appropriate transformation technique. We have many transformation technique, but we used here square root transformation as it transforming this skew distribution into normal. We can also use and log transformation, but we use square root transformation for normalization of this column. So now let's see the correlation matrix. For this correlation matrix, we can easily say that the temperature and dew temperature are highly correlated, which is good, but while training the model and doing prediction, it will badly affect on data. So this type of high correlation is also called as multicollinearity. We use VIF technique to detect multicollinearity separately, and then we decide to remove one of the column, which is dew point temperature. Now we will see the difference before removing and after removing this multicollinear column. Now multicollinearity detection, here we can see the result before and after the removing of dew point temperature column. So we can see that main difference here it is. So now coming forward, now we will see the modeling, what we use in our modeling, and which algos we used here. So these are algos, these are list of algos we used: linear regression, ridge, lasso, polynomial, decision tree regression, random forest regression, gradient boosting regression, extra tree regression. So let's take a look on our algos before hyperparameter tuning. We need to do hyperparameter tuning due to overfitting, because we can see here that random forest, gradient boost, and extra trees regression giving best ADJ RT score, but there are overfitting in them. So hyperparameter tuning is must. Now let's see the data after hyperparameter tuning. Here it is. Even after hyperparameter tuning, data frame showing the three best model visualization like extra tree regression, random forest, and decision tree. So here we decide our best model, which is our extra trees regression. Then according to our model evaluation matrix data frame, linear regression and polynomial is not giving best result. Decision tree and gradient boost have performed approximately equal good in terms of ADJ R2 and R2. So the best result that we getting from random forest and extra tree regression, but we are selecting the extra trees regression for model selection and prediction. So moving forward, here we see the visualization of error of best model, which we choose extra regression after seeing all models error between test and predicted data. So among all of them, extra regression give the less error compared to others. So this is the error scatter plot by using extra regression. Now moving forward, now we will discuss about the challenges we faced during project. So we felt a little challenging when we start working on different algorithms and it matrix, choosing quite a number of algorithms to work upon, as data sets was quite big enough, which need more computation time. Also deciding about the best model for prediction. So here it is, the analysis of and the prediction and the analysis of our project. So now let's take a look on conclusion. of our project, we observed that bike rental count is high during weekdays than weekend days. The rental bike counts is at peak at 8 a.m. in the morning and 6 p.m. in the evening. We observed that people prefer to rent bike during moderate to high temperature. Highest rental bike count is during autumn and summer season and the lowest in winter season. Our next conclusion is comparing the adjusted R2 among all models. Extra tree regression give the highest adjusted R2 score, that is 0.908699, and training score is 0.987167. Therefore, this model is best for predicting the bike rental counts on our basis. That's it. Thank you.